Hi everyone and welcome back to Waterhouse Forde. Well, we're getting to the end of it now. The last of three videos I mentioned a couple of videos back. So what we're going to do now, we need to just put the lift arms back on. We've got to get those last two bushes in, get the lift arms back on. We'll show you how to set up the lift arms. It's not a big job, it's not difficult, but it is something that's worth doing to make sure that they operate properly. And then if we get time, the last thing we'll do is just to put the draft control spring in and all the associated components. If we don't manage to get to that today, then we'll do that as a separate video. But for all intents and purposes, we hope to finish the transmission case today. So follow along and see how we do it. Okay, now before we move on to the actual lift arms, I just wanted to quickly talk about all the different parts. Obviously we've got the lift arms. We've actually done a little bit of pre-work just to get started. We put the lift arms on. We'll show you those in a minute. But these are all the other components that we need in order to complete primarily the lift arms and then also the draft control. Now, one of the parts in here was supplied by Anglo. This is A67628, and it's the spring support, the draft spring seat, if you want to think of it that way, which basically replaces these. So if you remember in one of the previous videos I talked about how this has been broken, that this came off in two parts, and that actually it should be one part, just like that. So that replaces that, so we don't need those anymore. The other thing I wanted to talk about, so these other things I already had the parts for, so I didn't need to get those from Anglo, but you can see this tin shield, that's obviously seriously damaged, so we're not going to use that. We've got a replacement here. I've just coated it with a base coat, a grey primer, obviously just to stop it from rusting and everything, so we don't need that anymore. And then again, the base plate, you can see that's fundamentally different. This one has a ridge on it. Again, I've just coated that with a grey primer, but on this one, that ridge is completely missing, and I believe it should be there. So again, we're going to forego that. So that leaves us then with obviously the draft spring, which in this case is still perfectly fine, and we're going to reuse that, no problem. The knuckle, and again, no problem with that. I've put a little bit of anti-seize on those threads to make sure that that goes in nice and smoothly, and more importantly that it doesn't seize and it can come out again later when it needs to be taken out. There's three new bolts for that triangular plate there. We then got the end caps for the lift arms, and I've made the new lock tabs, or lock tab plates. The old ones, the actual little tabs were pretty much non-existent. So, and I couldn't find these anywhere, so I ended up having to make them. It's just 1.2 millimeter flat sheet, and I obviously just cut those out, shape them, and those will go in on there. We've got new bolts for those. Again, two of those were damaged when we were taking the lift arm shaft out, so completely replaced new ones there. And then we've got the felt washer, which goes over this, or inside there, and over the draft arm, the draft spring arm, and that just helps to seal inside there and stop moisture from getting inside the transmission case. So these are still the bolts for the side covers. I haven't managed to get the replacements for those yet. I think what I'm going to end up having to do is actually cut to basically shorten 1 inch bolts. These are 3/4 inch. So I'm probably going to end up shortening the 1 inch bolts that I do have, because nobody seems to have the 3/4 inch long bolts.
Where did you get these from?
Well, these I got from another company called Spalding Fasteners. So they carry quite a wide range, and in particular they had what they call own color. So a lot of the ones that you buy today have been zinc coated, which is not a bad thing because obviously the zinc coating helps with anti-corrosion. But it's not, number one, it's not original, and also it's difficult to get the paint to stick to the zinc without a special treatment. So I decided to go for own color, which basically means they're just straight metal. There's no treatment, no real treatment. There's a little bit of what they call black Japanning that's happened there, but they don't have anything other than that. And that means that when we paint the tractor, the paint will hopefully stick nicely to it.
Have you checked for these there?
I have, yeah. So like I say, I've checked for the 3/4 inch length bolts. These are 7/16 UNC bolts, but they don't have the 3/4 inch. They only do the smallest, the shortest they do is 1 inch, which I've got a whole load of, but they don't do the 3/4, so we're going to have to shorten the 1 inch ones.
Okay.
Okay, right, shall we get on? So the first thing we're going to do is set the lift arms and show you how to do that. It's relatively easy and quite straightforward, so we'll do that quickly and then we'll get on with the draft control. 3. Right, as you can see, we've now got, we have already installed the lift arms onto the lift shaft, predominantly just because obviously it's a bit straightforward. Well, it's very straightforward, but more importantly, just a bit of hammering really, just to get them on. But they're on, they're connected to the shaft, we can hear the shaft moving inside there.
And we can move them really easily.
And they currently move very easily. We put a little bit of grease between the top cover and the lift arm itself on both sides, just to sort of ease that face. Now, what I want to show you is on the way I've set this up on either side. I'll bring the camera in a little bit closer. Just step
Why
back,
is
please,
it
Oscar.
clicking?
Right, so you can see here, hopefully you can see this, but the shaft is just inside this. So when I run my finger over there, I can feel an edge. And it's the same on both sides. So what that means is that the shaft is ever so slightly shorter than this total length across. And the reason for that is when we put these end plates on and we tighten them up, basically it's going to push this lift arm back against the top cover, and that creates a certain amount of tension in this slot here, and that sets the let's call it like the friction setting for the lift arms. Now the ultimate setting is where when you lift the lift arms up and you let them go, that they will gently drop under their own weight. Not that they will fall, but that they will slowly drop down, almost like a graceful fall down. And that's the right tension, that's the setting that we're looking for, and we're going to see how close we can get to that.
When we bring them up and down, why are they clicking?
So if you remember what's going on the inside, connected to the same shaft is the lever, the push lever.
Yeah.
And that has the piston connecting rod is connected to that. And when you move it, the piston connecting rod is moving in and out of the piston. Okay, so you don't want to do it too much because you might be scoring or damaging the inside of the cylinder. So it's probably better not to do it too much. But basically when you put pressure on into that cylinder, the piston is going to push up against that connecting rod, and it'll be sitting inside there.
Push these up.
And then it'll push those up, and when they go down, it'll push the piston back. Remember when we put the piston in the cylinder, we push the piston all the way to the bottom.
Yeah.
Now that's probably not its normal place, right? Normally it might not. It probably doesn't go all that way, all that far back. The reason we did that was to minimize the amount of air in the cylinder, right? So when we first fire it up, it's going to fill with oil rather than there being a whole bunch of air in there, like an air bubble.
Yeah.
Do you understand?
There'll be a little bit of air in the system, but we'll flush that out.
Well, it'll flush itself out. It works its way out. But the point is, when you put the piston in the cylinder, you push the piston all the way to the bottom so that the air gap is as small as possible.
Yeah.
Yeah?
So it probably isn't even touching it, or hardly.
Say again?
So the connecting rod is probably hardly even touching it.
Correct, yeah. Okay, so the next job is to put these end plates on. Now what we're going to do, we've got a little bit of copper grease here, also, anti-seize. We're just going to put a little bit of anti-seize on each of these bolts. You don't want to get your fingers on this because it's difficult to get off again. So we just spread that nicely around the threads.
So it won't damage your skin, it'll just...
No, it's just difficult to get off again. It's very sticky. So if you do yours, I'll stick.
Didn't even see them there.
Okay, so we've got a bit of anti-seize on there. Now, what we do is put the lock tab plate on. Put the two bolts through. And then pop them on into the shaft. Okay. Right, so both sides are now just finger tight, and we can see that the lift arms now do still fall too quickly. So what we want to do now is you take note of where the nuts are. So you have a look at the flat and basically tighten it one flat on each bolt. And the same on this side.
Tighten it or loosen it one flat, depending on...
Yeah, but we're tightening at the moment, right? So now, they're still falling too quickly, right? So we'll tighten it just a little bit more. Same on this side. Okay, now? Okay, so now they're too tight, right? They're not falling at all. So we know we need to loosen a little bit. Right, I'm going to leave it there. Obviously, it's got new bushes in. The shaft has been polished, and of course, we've got new faces or polished faces between the lift arm and the lift cover. So, I imagine it's going to ease up over time. And part of me would rather they were tight than loose. I wouldn't want them to just fall under their own, you know, as in fall violently, if you see what I mean. So I'd rather they were a little bit tight than too loose. So now we need to just bend over those lock tabs as best we can and try and lock those into place. So we just get a screwdriver.
Try and bend those over.
Okay. And now, hopefully without moving that bolt, we're going to just bend that down to hold that bolt in place. And we do the same for the bottom, And then we'll do the same for the other side as well. Okay, move on to the draft control now. So the first thing that goes on is this triangular plate that sits in there, like that. Now we need to put this felt washer on, and that's not obviously easy because the hole in the felt washer is quite a lot smaller than the shaft, so it has to be stretched over that.
Except you don't want to break it.
Yeah, you don't want to break it, but it's a tight fit, but it has to go on. So you probably help if you twisted it. You're getting in front of the camera. That's it. Keep going. Twist, twist, turn it, turn it.
It's on.
Okay, well done. Okay, and push that all the way down.
Into.
The next thing is the spring seat. That goes on there and sits inside that, like that. Okay. Then we get the tin plate, yeah, and the 3 bolts. Right, Oski,
Yeah.
let's get at least 1 bolt in there. Okay, I decided I wasn't very happy with the way that was sitting, so we took it off. And what I've done now, I've actually pressed this spring seat into this bottom plate. We've still got the fiber washer or the felt washer inside there. That's now trapped inside and can now go back over the shaft. So it might be a little bit difficult to get that on there, but that's better than the way it was sitting before, where basically the seat was completely skewed. So that's looking, I'm happy with that. We'll try that now. So we'll get this put the tin shield back on and get these bolts started again. But that's now sitting a lot straighter than it was before. And you can see that draft control lever now still runs up and down the center, which of course is important as well. So the next thing is to get the spring on and the knuckle.
Spring, knuckle, spring, knuckle,
Oscar, don't
spring,
be
knuckle.
silly.
First of all, spring, I think.
Yep.
And then
Now let's just get a little bit more anti-seize on there.
it's off.
There you go, right. Now that's a fine thread, so you need to make sure it's actually going before you force it.
Yeah, I can feel it's going.
Great. Right, now, as I said, I've said a couple of times now, it's not possible to set this. Okay, let me explain. Right, so there is a setting that's required here for the amount of, shall we call it, play in the system, in the draft control system, before it actually engages the hydraulics. So what you don't want is you don't want this to be basically affecting the hydraulics until it needs to. So when the implement is operating normally, there should be no effect from the draft control on the hydraulic control system. But equally, as soon as the draft control is required, in other words, for example, if you're ploughing, the plough becomes stuck, hits a rock, hits a big root or whatever, you want the draft control to react quickly. You don't want to, you don't want it to be sloppy because it needs to lift the plough as quickly as possible so that the tractor doesn't get stuck and you don't tip it. So there's a, shall we call it, a tolerance between how tight you want this to be. In other words, how much pressure it's actually placing. So the more you tighten this, the more it's pulling that lever inside the top cover out basically towards this knuckle. And obviously the more it's pulling, the more it's beginning to act on the control valve in the pump. So what Ferguson say now, you do have to have an implement on the hydraulics, or on the 3-point hitch rather, and then what you do is you take a feeler gauge, and what they say is that you want a gap between the spring and this flange on the knuckle. Now, they're not 100% specific about what that gap needs to be, but what I'm going to do is I would use a 10th thou gap. Now, that's the 10th thou feeler gauge. It's a little bit random because this face isn't 100% smooth. But you can see I can't get it in this side, but I can get it in this side. And that means that everything's not 100% lined up. But essentially, what we'll do for now is we'll just take that back half a turn. And hopefully, so we've got, now it's very loose on this side and it's still too tight on this side. It's not 100% precise. Again, you're dealing with a spring which doesn't have a 100% flat face, and obviously this flange, the face on this flange is not 100% either. But essentially what we're going to do, we're going to leave it there for now. So we know that we've got probably about 15 thou on this side and, well, nothing on this side. But once we get this all connected up and we've got an implement on the machine, on the tractor connected up, and you've got the weight of the implement on the hydraulic system, what you want to do is adjust that knuckle. So for that reason, we're not going to be connecting the back end, the back hitch to the knuckle. We're going to leave it. We will put, when we want to do the test, we'll just put a bar through there so it is connected, but it's not the final connection. We'll let it take up the weight, and then we want to basically judge roughly 10th thou gap between this flange and the spring, and that's how you would set up the draft control. So for now, we're going to leave it just like that. I don't know whether that's right or wrong. It's close. It's it's kind of there or thereabouts. But that's essentially what we'll be looking for when we get the tractor going and when we get everything set up.
Why didn't we count how many turns it was when we were taking it off?
Well, because we completely replaced a whole bunch of stuff in here, right? So even it doesn't matter what the setting was, it will be different now, right? Yeah. Also, we didn't know the state of that shaft or this knuckle. We may have had to have replaced them. So until you get it off, you don't know. So there's little point. It's a good idea, but there's not very much point in in counting it to how it was, because a lot of stuff will have changed between then and now.
Yeah.
Okay?
Yeah.
Great. Okay. Okay, so Is yours difficult?
Oh, you got the easy one.
I got the easy one. Right. Right, that side's in. This side is proving a little bit more difficult. I mean, it probably just needs a little bit of... There we go, just lift it, you see? Hold that as best you can, yeah?
Okay.
Put your weight against it.
Whoa.
Okay, so other than putting the side covers onto the transmission housing, which we're not going to do today, as I said, we need to get those bolts sorted out. But I'm sure you don't need to see how to put 12 bolts in. So we're going to leave it there. We're going to call the transmission housing done. As I say, the side covers need to go on. One other thing that does need to be done is we still need to sort out this quadrant. We'll do that as a separate video. We're not 100% ready to do that yet. I've still got some cleaning to do on the lever. I'm not happy with how that's come out, so I want to have another go at that. But we'll do that as a separate video because it's actually quite an interesting setup there as well with a friction disc and all of that needs to go in there as well. So we're going to call it there for today. Thank you very much again to Anglo Agri-Parts for supplying the parts for our restoration and for sponsoring the channel. Please visit their website at www.angloagriparts.com and obviously support them. I'm sure that they'll help you to find the parts that you're looking for your project. So from Oscar and I, thank you very much and goodbye.
Bye.